Hello, this is Marina Cow and this is lab number 2, motion of a falling object. In this lab, the system is the falling object and the surrounding is the world. This experiment focuses on the motion of a falling object, so the net force on this falling object is going to be the gravitational force, and the purpose of this experiment is to have a deeper understanding of Newton's second law and the effect of drag force on any moving objects. To start off, the Newton's second law states that the acceleration of an object is dependent upon two variables, the net force acting upon the object and the mass of the object. As you can see on the equation on the right, so the net force is equal to the mass of the object times the acceleration. And to define drag force, drag is a force acting opposite to the relative motion of any object moving with respect to a surrounding fluid. This is a video from Tracker, and in this video, I dropped a small stuffed animal about 2 meters above the ground. And as you can see from the graphs on the top right area, the relationship between the disposition and the mass of the object is not linear, which makes sense because the velocity of this object is not constant. It has a gravitational force acting upon it, which means it has an acceleration of about 9.8 meters per second. This is the globe script code where the object is not experiencing any drag force. And this is the globe script code under the circumstance where the falling object is experiencing a drag force. I would like to draw your attention to this particular part of my code. So the one from above is from the code with no drag force, and the one from below is the code with drag force. And as you can see, for line 70 and 71, there is a drag force applied on the net force. So it's not only the gravitational force and the mass of the ball, but also the drag force too. I compared the data I collected from Tracker with the two computational models I showed in the previous slides. And from the Excel chart down below, you can see that there is a larger overlapped area with the observed values from Tracker than the predicted values with drag force. And that makes sense because in reality, there is a drag force acting upon the object from the air resistant. However, even with the predicted value with no drag force, the deviation is pretty moderate, and that indicates that my data accuracy is pretty high. However, I would like to address that there is still some room for potential error. For example, I might be making some minor error tracking the object's movement on the app Tracker. To answer the what does it mean question, I examined the velocity versus time predicted by my computational models with and without drag. The model with drag predicts a terminal velocity, so a terminal velocity happens when the force of drag pointing up has exactly balanced the force of gravity pointing down. As you can see from the graph with drag force present, the slope of velocity decreases as time goes by. This means that the drag force is slowly approaching the gravitational force acting upon the falling object, and in this case the net force is slowly approaching zero, and that's when the object reaches the terminal velocity. My answer to this what if question is that the terminal velocity in this case will be the same from the case where it is dropped from the rest. This is because the terminal velocity is specific to the object, not object's initial velocity, so it doesn't matter how the object was initially thrown downwards or dropped from the rest.